Hi folks, and welcome to this Matplotlib Crash Course. So today I'm going to show you some of the basics of in and around Matplotlib using Python. We're going to go through how to create a Conda environment, install the Matplotlib libraries, and run through some of the basic graphs and customizations that you can do. Visualizing your data is a very important part of the exploratory data analysis phase, and it can be done with relative ease using Matplotlib. So let's jump in and create our new Conda environment. So if we just jump, I've got an Anaconda navigator open here. I'll leave a link in the description on where you can actually install Anaconda navigator. But once you've got this open up, click on environments, scroll down to here. We want to create a new environment, Matplotlib. We want to use Python 3.7, that's fine. And that will go ahead and create your new environment. This takes a few seconds, so I'll check back in once that has been completed. Cool, so that is our new environment created. Let's go back to home and we will now install Jupyter Notebooks. And again, this takes a few moments, so let me just check back in once this is completed. So once Jupyter has installed, you're presented with this file navigation aid here. So I've created a new folder on my desktop and stored a data file in there. So I'll put the link to in the description box to where you can get this data, and you can replicate this tutorial if you wish. But here we're going to create a new Jupyter notebook. So new Python 3. I will name this Matplotlib tutorial. Rename that. And first, which we wanted to do is try and import our dependencies. So pandas as PD. So you can see that our dependencies aren't in place. So we need to go back to our Anaconda navigator and install them. So that's us back in Anaconda navigator. Let's go to environment, click on our Matplotlib, and if we go to this drop down here, we can see which ones are installed and which ones aren't. So what we want to do is look for pandas. Is that there? You can hit apply. So this is going to download that package. Has a few dependencies. Now let's do the same for Matplotlib. And we will install that. Again, this comes with some dependencies as well. We don't need to install NumPy as that comes with pandas, so let me just check back in once this is completed. Cool, so that's completed. Let's jump back into our Jupyter notebook. Okay, so if we now try to rerun this, it's worked okay. So let's load in the rest of our dependencies. So load the dependencies to import numpy as MP, spell mistake there, and we want to import matplotlib.pyplot as plt. We want to add in this special command here, which allows us to view our graphs inline in this Jupyter Notebooks. So let's run this. And that's worked successfully. So the data I've got for this crash course is some online sales data relating to retail. I think I picked it up off Kaggle. I'll put a link to the file in the description box, but let's first get it loaded in and see what it looks like. So sales data equals pd.read csv OnlineRetail.csv coding equals ISO 8859-1. So I've had to add some special encoding in here just so that pandas can read it correctly. So if we go sales data dot head, let our data load in and see what it looks like. So yeah, typical sales data. I've got some invoice numbers here, stock code, quantity of a unit price, invoice date. Cool. So let's pre-process data a bit more and add in a year and a month column. So add a new column in pandas is quite easy. Just give the name of what you want in there, and we'll use pd.datetime index. And we'll use the invoice date to grab the month. Oh, sorry, year. And we will do the same for month. And, oh, that should be date. And let's run that just to make sure that's worked fine. Okay, that's worked fine. So I think it'd be useful to have a total price column as well. So let's just add that in. Sales data total price equals sales data. And the total price will be the quantity multiplied by the unit price. Quantity quan multiplied by sales data unit price. Let's rerun that. Perfect, so that's worked fine. Next, I am going to check the size of this data frame. I don't think we need to work with all the data in here, and we can simply do that by calling the shape function on the frame. In fact, let me just cancel that and put this through. Here. So that we're not just working with the recalling the read CSV all the time, as it takes a little time to run. Yeah, we've got 540,000 records here. Yeah, so let's reduce these slightly so we can pre-select some customers, and again using some pandas filtering. This makes it quite simple. So we'll just choose a few customers. We can use it as in and pass that an array. I've already had a look at the data and picked out these two customers in particular. And let's just reset the pandas index. Do it in place. So we're using pandas here quite a lot. Drop me a comment in the comment box if you want me to go through pandas in more detail. I can certainly put up a video on that. So let's rerun that again. Okay, that's finished. Let's have a look at the shape now, and we can see we've greatly reduced the number of rows in here. So I think that's all we need to do for the data pre-processing. So let's jump in and create our first line chart. So creating a line chart is very simple using Matplotlib. So we just have to call our alias. So if you remember up here, we gave the Matplotlib PyPlot library an alias, pltplot, and it only needs one argument, so we can view the total price. So if you just pass in the one argument, it will put the price on the y-axis, and then it will use the index of the pandas data frame for the x-axis. So we'll just run that, and there we go, we've created our first graph. So you can see we had roughly about 764 rows, and that goes to about 764 there. Looks like we've maybe got some refunds in there, things falling below the 0 on the y-axis. Cool. So for this next example, we're going to pass in a custom x-axis. So we need to do a little bit more data pre-processing here. So we can say yearly sales. What we'll do is we'll view the total monthly sales of these two customers. So yearly sales of 2011 equals sales data. We can say sales data year dot is in, and we want to pass in 2011. So the monthly sales, what we need to do here is group the total sales by month, sorry. So we can say monthly sales equals, again this is quite panda orientated here, but it lets us produce some meaningful graphs. So group by, the group by function by pandas is quite similar to, if you're familiar with SQL, it works in the same manner. So we want to group by the month, and we want to sum all the values. So I'll just show you what that looks like in tabular form. Oh, made a little error here. And sales data. So you can see we have all the months here, and we have the total prices. So these are the total sales for this year for these particular customers. So one other thing we need to do here is reset the index to get, so you can see the month is now the index here, so we need to reset that to bring it back into frame. True. We can just call monthly sales again. Perfect, and it has the index has been reset back to normal. So now we can create a new graph passing in the month as the x-axis. So again, just call plot. Monthly sales. So when you're passing in that x value, that goes in first. And we can see monthly sales, total price. And there we have it. So this is the total sales over the year of 2011. So that's pretty cool. So another graph that we can do is the histogram. Again, very simple to do. Plt hist is the function name, and we can just pass in a set of values. Simple as that. So what we have here on the top array is the counts of the buckets, and a second array we have where the buckets start and stop. The histogram is good for visualizing the frequency of the distribution, and it makes its own attempt at the bin selection, so that's what the bottom array is. So we can now move on to our next chart, and we can just do a quick example of the bar chart. So plt, and the function for this is bar. So the bar chart accepts 2 iterables. So we already have some data pre-processed for that, so we can visualize the monthly sales again. So month, and we want the total price. Cool, so this is basically this chart here and this one here, these are the same, just showing the data in a different way. Like line graphs are usually more, you can see trends in them more compared to a bar graph. Again, the x-axis goes first, the y-axis second is the second argument. And we can also create horizontal bar charts. So if I just copy that, and the function for creating a horizontal bar chart is just bar h. And what the horizontal bar graph allows us to do is just visualize the data in a different way. So we can see the x-axis has moved up to the y-axis and vice versa. So I'm going to have a look at another bar chart example and just show you sometimes that Matplotlib doesn't get the x-axis correct and what we can do to fix that. So what I'm going to do here is just visualize the sum of the total sales by year. So we've got data for 2010 and 2011, so I want to see that in a bar graph. So let's just do some data pre-processing. year sum. Want to use sales data dot group by. We want to group our data by year, and we want to aggregate it using this sum. And you can see what that looks like. So that's the data there. So let's just reset the index and get the year back into, get that index column back into a normal column. And just use in place again equals true. Perfect. So what we can do now is plot the total sales, plot.bar, use sales data, year, by year sum, total price. Got a small error here. Perfect. Alright, it's very clear what we're trying to visualize here. So what we can do with that is actually pass in our own. So we can use that using the xticks function. And we can just pass in that above function again. Yeah, Matplotlib tries its best to guess the x-axis from the values it's given. So we can manually override that using the xticks function, and you can see the graph is much more clearer now. In the next example, we're going to have a look at the stacked bar chart. So what we can visualize here is what we've just visualized above using the total yearly sales. But let's see how each customer has contributed to that. So again, we're going to have to do a little bit of data pre-processing. So we'll say filter by customer equals sales data. Again, we want to group by, and this time we want to group it by year and customer ID. Using a sum aggregate. And that's what that data looks like. So again, let's just reset the index. In place equals true. Now we want to filter our data so that we have customer specific data frames. So we know that we have a customer called, or a customer ID 17581 and 17850. So we say cost 17581 equals, use a new data frame we just created, and we can filter by year. Customer, we want to use a customer ID equals and this is 17581. Cool, and that ran fine. So if we have a look here, we should see how many sales per year this customer done. We can now replicate that for another customer. So we can say customer 17850. Let's change that 17850. And that's worked okay. So now we can actually plot the stacked bar graph. So to create a stacked bar graph, we call the plot.bar again. And what we want to do for the first or the bottom is year. We want to call that unique function again. And we want the y-axis to be the total price, and to stack it we just call the function again. So this time it will be customer 17850 year dot unique. Again, the total price, and we need to pass this in a bottom parameter equal to the top here. So we can just copy this. So what we're saying here is we want this graph to start on the bottom, on the top of this. If we just run that, and you can see that we have a stacked bar graph again. Our x-axis hasn't been created the way we would like it, so we can run the plt xticks and just pass this in the sales data dot unique, and there we have it. We've got a stacked bar graph. So we have the total sales for 2010 and 2011 for each customer. Customer 17581, customer 17850, and we can see how they've contributed to these total sales. Let's go and have a look at our next example, which will be a pie chart. I'm not a massive fan of the pie chart, as I think it can be quite hard to visualize with the smaller slices of the pie, but I'm going to go through how to create one anyway. So simple plot.pie, and what we can say here is just use the data from above. So we have a pie chart here, and it's visualizing the total sales, what that actually looks like. So you can see that 2011 is orange, 2010 is 12. Probably worth mentioning at this point that if you want to get rid of some of the data that Matplotlib puts in, you can just add a semicolon to the end of your graphs, and that gets rid of it. So we can actually add some labels to our graph to make it easier to visualize. So I'll just copy that and you just pass in the an iterable into the labels value. So what we want to say here is we want to see the years. And now we can see what year is attached to what slice of the pie. We can also customize this a bit further by asking Matplotlib to give us the percentages of each slice of the pie. I can just copy and paste this. And we want to use the auto %, and we just pass this in a string in the format of the percentage that we want to use. So if we run that, you can see that over 2010-2011 the total sales 61.6% fell in 2011. You can change the decimal notation here, 61.56. One other thing you can do is, to make it easier to visualize, is explode parts of the pie. So again, we're just using another parameter in the pie function. So we can say explosions equals mp dot zeros. So we're creating a explosions. So we're creating a zero array here, and we want to now change the first value to 0.5. So essentially what we want to do is create an array to equal the number of slices in the pie, and we want to now explode out the first slice in the pie. So we can just copy this section here again. We can use explode equals explosions. And yeah, this pushes the data further away. So again, it just makes it slightly more easier to see what's going on. So another graph that Matplotlib can produce is the scatterplot. And as you probably guessed, we just call scatter. So what we'll do here is visualize the total price to quantity to see if there's any correlation here. Run that. Cool, so we can see that usually the more quantity that's bought, the higher the total price, which is probably to be expected. But yeah, it does look like there's a few outliers in there as well. Most of the data looks like it's centered towards low quantities and total values. So I'm going to wrap this Matplotlib Crash Course up here. So drop the video a like if you enjoyed this content, and let me know in the comments box below on what more content you would like to see. Thanks for watching.